think the first 3 sections of chapter 5 are actually like they make a lot of sense. They're all connected together. The last 2 sections, not that they don't make sense, but they're just kind of like the kind of like extra little rules. And we started 5.4 on Monday. So remember, these were called the sum and difference formulas. So the first thing that I want to do is I want to chop off this 35 through 41. So you only have to go 1 through 29 odd. So that's an important thing to note. Okay. And really what this section is about and the next section is about is just kind of applying these formulas. For the quiz, I will give you this blue box for reference. Okay. And then also I will give you these 2 blue boxes for reference. So it's really about knowing how to use the formulas, not necessarily memorizing them and using them like all the time. Does that make sense? So it's really about understanding how to use them more than necessarily like memorizing them. Okay, so let's go ahead and get started. Print screen. We did some of these on Monday. So what these are is if you need to find, for example, the sine of, let's see, you want to find the exact value of the sine of, I'm just looking here, 5 pi over 12. Okay, so this is number 20. I want to find the exact value for the sine of 5 pi over 12. And plugging into Desmos just won't do. I want to find the exact value. Okay, so what you can do is we can use this idea of the sum and difference formulas to come up with values that we do know and then just basically plug it in. Okay, so for example, number 20, actually you want to find the sine, cosine, and tangent of that, but let's start with the sine. If I want to take the sine of 5 pi over 12, if you go to your unit circle and you look for 5 pi over 12, you're going to be looking for a long time because it doesn't show up on your unit circle. Boo, right? I thought everything was on the unit circle. But what you can do is you can say, well, what if I can break this down into some values that are on my unit circle? Okay, so if I look at 5 pi over 12, I could think of that as 3 pi over 12 plus 2 pi over 12. And let's see if I simplify those two, if those look like things on my unit circle. So sine of 3 pi over 12 is a sine of pi over 4 plus the sine of pi over 6. Okay, are those two values, pi over 4 and pi over 6, on my unit circle? Let's look. Yeah, pi over 6 is at 30 degrees and pi over 4 is at 45 degrees. Okay, so if I add this together, 5 pi over 12 should be at 75 degrees. So I basically want to find the exact value of that. So if I want to do that, right, what I can use is I can use the sum or difference formula. Okay, so I have the sine of 4 over, I have the sine of pi over 4 plus pi over 6. And I can rewrite that as, I'm going to need a lot of room, the sine of the first one, which is pi over 4. Okay, the sine of pi over 4 times the cosine of pi over 6 plus the cosine of pi over 4 times the sine of pi over 6. So basically in this case, u is pi over 4 and V is pi over 6. So now when I look at my unit circle, the sine of pi over 4 is the square root of 2 over 2. Okay, sorry for writing in there. The cosine of pi over 6 is the square root of 3 over 2. Okay. The cosine of pi over 4 is the square root of 2 over 2. And the sine of pi over 6 is 1/2. So when I simplify this, I get the square root of 6 over 4 plus the square root of 2 over 4, or the square root of 6 plus the square root of 2 over 4. That's my exact value for the sine of 5 pi over 2. So how can I double check this pretty quickly? I could go to Desmos, right? Somewhere is Desmos. Here we go. Can go to Desmos and I can plug it in. First of all, I want to make sure I'm in radians, right? That's in radians. That's good. Okay, so if I do the sine of 5 pi divided by 12, I get 9.96594, right? If I do the square root of 6, plus the square root of 2, okay, and I divide that by 4, I also get 96592, blah, 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 blah. All right, so this is the exact value of the sine of 5 pi over 12. All right. So I think if I'm looking right, yes, if I'm looking right, that is, so that's 7 through 21. That's how you do those. Does that make sense? What I'm doing, how I'm plugging it in, and how I'm coming up with these values to plug in? Does that make sense?
It makes sense.
Cool. Mackenzie says yes. I think Sarah's good. Okay. Do you guys want more examples of that? Or it's just, I mean, it really is just a plug in and look at it. All right. Good. Okay. So then, like I said, you only need to do 1 through 29. We're going to chop off 35 through 41. So actually 23 through 29, I'll have to double check. Yes, 23 to 29 are actually, I think, easier than the other ones. You know how sometimes they do that when you get the further ones along and like, this seems a little bit easier to me personally. So what I mean by that is if you look at number, let's say, there we go. If you look at number 24, okay, number 24 says, write the expression as the sine, cosine, or tangent of an angle. So number 24 is the sine of, the sine of 110 times the cosine of 80 plus the cosine of 110 times the sine of 80. So what this is they've actually given you, okay. They've given you the broken out part and you have to basically go backwards and figure out what it is. So this has a sine, then a cosine, and a sine. So this one happens to be the one that we've just done before, right? Because you have a sine and a cosine plus a cosine and a sine. There's no negative there. So because of that, I know that that means that U equals 110 degrees and V equals 80 degrees. So this is really just like the sine of 110 plus 80 degrees, or the sine of 190 degrees. So that's what you would literally write, is that this is the sine of 190 degrees. So you're basically uncalculating what you would have done. Okay. One thing I realized that we have not done is we didn't do one with a tangent yet. So maybe we should do one with a tangent using the tangent formulas. I mean, sine, if you add or subtract, or cosine, if you add or subtract, those all make sense, I think. Let's do, I'm just looking for one on my paper that I have done. All right, let's do number 12 but find the tangent for number 12, and then we'll look at number 26 and kind of see how that relates. Okay, so number 12, nope, don't want to do that. All right, so it's like a really funky favorite property. I like it, Sarah. You always have a good outlook on things. All right, so number 12, remember they actually broke it out for you. Number 12, they told you. I don't know what my deal is today. I want to really just draw all over everything. So number 12, they actually broke up the problem for you, right? So they tell you that 17 pi over 12 equals 7 pi over 6 plus pi over 4. They actually tell you what it is. So let's do this for the tangent. Okay, so the tangent of 17 pi, oh man, over 6. This is over 12. This is part of number 12 that I'm doing here. That's why I was trying to write that. Okay. Is equal to the tangent of 7 pi over 6, okay, plus pi over 4. So then we look over here at our properties, and if we have the tangent of one number plus another number, okay, you're going to use this formula here. So your u is going to be 7 pi over 6, and your v is going to be pi over 4. So it's going to be the tangent of 7 pi over 6 plus the tangent of pi over 4 divided by 1 minus the tangent of 7 pi over 6 times the tangent of pi over 4. So again, it's just another plug-in, but it's kind of not as pretty. Not as pretty of a plug-in, right? Okay. So what is the tangent of 7 pi over 6? So if you look at your unit circle, 7 pi over 6 is, where can I write this? I'll write it in. Who needs all these other words, right? We'll just erase all those guys. All right. With a red box, sure. Because I can't work paint today. All right, so let's look at what is the tangent of 7 pi over 6. Well, remember the tangent is the sine over the cosine. So the sine of 7 pi over 6 is -1/2. And the cosine of 7 pi over 6 is -√3 over 2. So if I simplify this, the negatives cross off, the 2's in the denominators cross off, and you get 1 over the square root of 3, which we don't totally love, but we're going to kind of leave it there for now. Okay, so then how do I do the tangent of pi over 4? So again, the tangent of pi over 4, man, my writing is sloppy, is the sine over the cosine. So it's the square root of 2 over 2. That's the sine of pi over 4. And the cosine is also the square root of 2 over 2. So the tangent of pi over 4 is actually 1. So once you figure these out off to the side, then you plug them in. And then we'll do some simplifying. Don't worry, we won't leave that square root in the bottom. So we have 1 over the square root of 3 plus 1, right, over 1 minus 1 over the square root of 3 times 1. Okay, now this looks like fun, right? Let's see. Let's do some simplifying. Let's, what would be the easiest way to do this? There's multiple ways you could do this. I'm thinking about multiplying everything by the square root of 3. Like multiply the top and the bottom by square root of 3, and then we'll get rid of all the square roots, right? So the square root of 3 times 1 over the square root of 3 is 1. The square root of 3 times 1 is the square root of 3, right? Square root of 3 times 1 is the square root of 3. And the square root of 3 times 1 over the square root of 3 is 1. Right? So this will be one evaluation of the tangent of 17 pi over 12. It's so beautiful, right? Again, if you type these into Desmos, if I did them right, they should give you the right answer. I have a different answer on my paper, but I think it's just a different evaluation. So we will see. This might be one of those cases where I'm like, oh, I did somewhere in the math wrong. All right, so we're doing the tangent of 17 pi over 12. And I'm saying that that is 1. No, I don't need all this stuff. 1 plus the square root of 3. Nope, I need a thing here. There we go. Divided by the square root of 3 minus 1. Oh, yay, we did it right. All right, there we go. So this expression here is the tangent of 17 pi over 12. Okay. I'm going to be completely honest with you right now. I don't know how many times in higher level math I had to give the value in this form. A lot of times you would just leave it in this until you evaluated it and rounded it to a nearest place. But feel it is my duty as your pre-calculus teacher to show you that there is a property so that you can find the exact value if you don't want to get 3.732, whatever. You can evaluate it as a set of square roots. Okay, so that's how you would do one with tangent. Very fun, right? So continuing on in that same idea, okay, is section 5.5, which is the multiple angle formula. Oops. Here, hold on. So if one is you want to find the exact function. Okay, great. Right? This is a different way you can find a property. This is if you have 2 times your angle, you can evaluate it, or if you have half your angle, you can evaluate it. All right, so what this means is that let's take I'm just looking at a good one here. Let's take a really easy one. Okay, so if you were doing the sine of pi over 6, okay, no, hold on. You're doing the sine of pi over 3. which we can totally look at the unit circle and we know that the sine of pi over 3 is the square root of 3 over 2. So you wouldn't necessarily use this method for this, but I just want to prove that it works, okay? Another way you could think of the sine of pi over 3 is that that is the sine of 2 times pi over 6. Okay, those are the same thing. And we have a formula when you have 2 times a number, you can actually rewrite it as 2 times the sine of pi over 6 times the cosine of pi over 6. Okay, so your u is pi over 6, and you can plug it into this formula. So let's see if it works. The sine of pi over 6 is, sine of pi over 6 is 1/2. And the cosine of pi over 6 is the square root of 3 over 2. And if I multiply those all out, I end up with the square root of 3 over 2, which is what my original sine is. So again, it's another way of kind of, if you don't know the exact value on your unit circle for an angle, then you can either use you can add, break it down into adding 2 angles together or subtracting 2 angles. Or if it's double an angle or half of an angle that you can use any of these formulas here. Okay, so it's another plug-in, use your unit circle to kind of figure it out. All right, for this one, I'm going to change up your homework a little bit. So for this one, I want you to do 1 through 17 odd. And then I want you to do 39 and 41. Okay. So let me write that down. Let me put it in the chat. So for 5.5, it's 1 through 17 odd and 39 and 41. Okay, so let's kind of go through a couple of these so you can see. Let's do number 14. Okay, so the reason I'm skipping a little bit is because 14 covers number 2. And in 13 through 12, it says use a graphing utility to approximate the solutions to the equation. So I guess we could do number 4 really quickly because that won't take very long at all, right? So number 4 is the sine of 2x plus the cosine of x equals 0. So what are my approximate solutions to that? And it's over the interval of 0 to 2 pi. So the sine of 2x plus the cosine of x. We want to know, where does that equal 0? Okay. And we want to go between, oh, bummer, I thought it would be in. We basically want to go between 0 and 2 pi. Okay. So where are all the places it equals 0? It equals 0 at pi over 2. 7 pi over 6, 3 pi over 2, and 11 pi over 6. So that's how you would find all the values for that. Okay. So I think those should be pretty easy. So then let's skip to something like number 14. Copy that. Let's put that here. All right, so we want to find the exact values of our function using the double angle formula. Okay, so what this looks like is this. They tell you that the cosine, and this looks a little different than the other one. So the cosine of u equals -2/7. So I want to know what the sine of 2u is, the cosine of 2u, and the tangent of 2u. Okay, so what you're actually going to want to do for these problems, a little bit different than, it's a little bit different than the last section. So what you're going to want to do is you're going to want to actually draw a picture of what we kind of have going on. So you know that the cosine, well, one thing is it tells you that u, this letter u, is between pi over 2 and pi. So if you remember your unit circle or you have it sitting there, you know that it's going to be in this quadrant over here, in your second quadrant. Okay. The cosine, right? The cosine of your u is, think about your SOHCAHTOA, is equal to your adjacent side over your hypotenuse. Right? So then if I wanted to find my other side, could I do that? So these are a little bit weird. So if I wanted to find what my opposite side is, could I do that? I could, and I can use Pythagoras, right? So I know that 2 squared plus my opposite side squared equals 7 squared. So this is 4 plus my opposite side squared equals 49, or my opposite side equals 45, or it equals the square root of 45. So this side over here is the square root of 45. I feel like this is so messy. It's like driving me crazy. All right. So now I kind of have my triangle set up, right? Here is u. This is -2. This is the square root of 45. And this is 7. So I know that the cosine, because they tell me this, of u is -2/7. The sine of u is square root of 45/7. And the tangent, right, is opposite over adjacent, is the square root of 45/2. So now if I want to find the sine of 2u, I need more space. Oh, we'll just erase that. Okay. If I want to find the sine of 2u, I know that the sine of 2u is 2 times the sine of u times the cosine of u. All right. I know that the sine of u is square root of 45 over 7. And the cosine of u is negative 2 over 7. So if I multiply this all out, I get negative 4 square root of 45 over 49. That's 2, the sine of 2u is equal to that. Okay, and then the cosine, okay, the cosine of 2u, if I go back up here, the cosine of 2u equals 1 minus 2 times the sine squared of u. So the cosine of 2u equals 1 minus the sine squared of sine squared of u. Okay, 1 minus, what is the sine of u? It's square root of 45 over 7 squared. So it's 1 minus 45 over 49. And then you can actually simplify that and you would get 4/49 is the cosine of 2u. Okay. And then the tangent is just, again, another formula that you plug in. So it's pretty weird how you do it, but I think it's something once you start trying it, I think you should be okay. The half cosine you kind of do in the same way. So let me do one of those really quickly. I hope I didn't lose you guys completely. I know that it's almost holiday break, so I'm sure you guys are all like, oh, okay. Okay, so the last one I want to do is number 40. Okay, so this says basically for 39 and 41, use the half angle formula to determine the exact values of the sine, cosine, and tangent of the angle. Okay, so this tells me that we have 165 degrees, maybe. There we go. 165 degrees, and I want to use the half formula to figure out my values. Okay, so this is a little bit funky because basically what you're saying is u divided by half is going to equal 160 because you want to find the sine of 165. Sorry, not 160, 165. So in order to find the sine of 165, you want u divided by 2 to equal 165. So that means that u actually equals 330 degrees. And that's a good thing because 165 degrees is not on my unit circle, but 330 degrees is on my unit circle. Okay, so for example, if I'm finding the sine of 165 degrees, right, I use this formula. It's plus or minus the square root of 1 minus the cosine of 330 degrees divided by 2. So it's plus or minus 1 minus the cosine of 330 degrees. So that is negative 1/2 over 2. So 1 minus 1/2 is 1/2 divided by 2 is 1/4. So it's plus or minus the square root of 1/4 is what the sine of 165 degrees is. Okay, and then if I double check that, by using Desmos, right? The sine of 165 degrees, and I'm going to have to switch to degrees because I'm in radians, should equal the square root of 1/4. Right now they don't equal that. Oh, the square root of 1/4 is 1/2. Sorry, I don't even, and my brain didn't even realize that. Uh-oh, something went wrong. So this should be right when I change it to degrees. The sine of 165 degrees. Do something wrong with my math here. It's possible. The cosine, oh, this is negative. Sorry, that's negative. So then you would actually add together. Sorry, this would be wrong. You would do 1 plus 1/2. So it would be 3 over 2 over 2, or the square root of 3 over 4. So that something still went wrong. I did something wrong with that. 3 over 4. All right, my math following along, people. What did I do wrong? 1 plus 1/2 is 3 over 2 divided by 2. Yeah, I did something right there. That's what I get for not doing one of my examples that's on the paper. I always pick the wrong one. All right, well, I'm gonna have to look at that since it's kind of the end here. So let me figure out what I did wrong with that. But the idea still kind of remains the same. Okay. Thank you guys so much for coming today. I know it was just like a lot of information kind of thrown at you, but I think we should be able to do these last few. We will have time on Monday to go over any questions, go over any problems, go play game if we run out of time. So Monday, basically catch up review. We'll do anything that, any questions that you might have. All right. Thanks for sticking with me today, guys, and I hope you have a good weekend. Yeah, I'll bring happy salmon, Sarah.
Thank you.
All right, thanks, Connor. Have a good one. Bye, guys. Thanks. See you Monday.